All right, everybody, welcome back to class. Hope you enjoyed your little break there. We are going to jump ahead to activity 1.3 in your textbook. Again, we're working out of volume 1. The page number is M1-13. So our situation here is a little bit different than the one that we just did. I think I mentioned this one's a little bit more involved, more complicated, but I feel like it makes a lot of sense still. So we've got two people, Maureen and Matthew, and they're designing a backyard patio. There's going to have an entrance and an exit, and the sequence shown represents different designs depending on the size of their patio, of what they can fit, I guess. Analyze each design of the sequence, describe as many patterns as you can. Okay, so I guess right off the bat, this shape is obviously a lot more irregular than the one that we just did. It's not a square anymore. So there should be more patterns developing, but on the plus side, we don't have to worry about colors anymore. So hey, let me jot some notes down about this, analyze each design. So hey, this first design, second design, third design, they all have one thing in common. They all have an entrance, one exit, and that's it. One entrance, one exit. So we've got two tiles coming from the entrance and exit, put together, and that is never changing. So they all have that in common. This one, we don't have, if we eliminated the entrance and the exit, we've got this little slender rectangle. Looks like the length is the length here, the length this way is 1, and then the width is 3. So I'm going to jot that down actually. We've got a length of 1. Again, I just like to organize using tables. It's kind of my go-to. You can do whatever you want, draw pictures, just kind of write out what's happening. This is definitely my strategy at least. So we got a length and a width. Our length on the first patio is 1. The width is 3. Design number 2, the length is 2. And the width is 1, 2, 3, 4. All right, so it kind of seems like we have a pattern here. Design number 3, length of 3, width of, what am I doing the wrong way? The width of 1, 2, 3, 4, 5. Length 3, width 5. I probably should have labeled that differently. It's all good. Hey, let's keep going. Patterns, right? So length and width, length comma width, right? Length and width, they go up by 1. We add 1 to the length, we add 1 to the width every single time. Another pattern maybe is the width, right? Do you guys kind of see what's going on between the length and the width? We know they're each increasing by 1, but the width is always 2 more. The width is always 2 more than the length. Atrocious handwriting. Apologize. So anyhow, I think we have enough to go with. Those are a pretty good amount of patterns. Possibly one more thing that we should definitely look at is the number of tiles. So we've got a design, right? We've got a design, and we've got a total number of tiles. So I'm going to put T for tiles. So in design 1, we've got 5 tiles. Design number 2, we've got the 2 tiles for the entrance and exit. I can try zooming in a bit, maybe not. So we've got a rectangle, right? 2 by 4, that's 8. Add in the entrance and exit, so we've got 10 tiles there altogether. Number 3, I'm thinking that's probably going to end up being the easiest way to go about doing this. The length and width of just the rectangle. So we've got 3 by 5, which is 15. Add the entrance and exit, so we've got 17 tiles total. Okay. This table might be important later, I don't know. Let's go ahead and move on to question number 2. If you got other designs, it's perfect. Other patterns that you notice, that's just what I'm seeing, right off the bat. Hey, so let me scroll down to the next question. Sketch design number 6. All right, let's clear all this. Okay, design number 6. So this might be a little bit of a process. What is design number 6 going to look like? I think maybe the easiest way to start is, let's just go to this top corner right here. Actually, let's go to that top left corner, and let's make that our exit or entrance. I don't really care either way. All right. So I established this direction as being the length. It seemed like the length and the design were always the same amount. The length of just the rectangle, right? So that first design, the length was 1. Remember, the second design, the length was 2, so on and so on. So that would mean our length here is going to be 6. So I go 1, 2, 3, 4, 5, and then 6. I think I got 6 there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Son of a. There we go. So we got the entrance and then 6 for just the rectangle. What a struggle. Hey, so then the width going this direction, right, going this way, was always 2 more than our length. So let's go ahead and draw on that. So that would mean 8. We got a width of 8. So hey, 1, 2, 3, 4, 5, 6, 7, 8. All right, I'm just going to try to sketch in a rectangle here. And I did a perfect job right on. And that looks good. Hey, and then I'm just going to add right here my, this looks amazing, my exit. That is a solid sketch. All right. So hopefully you guys kind of use the same strategies though. I know what the length's going to be. That was easy to find. And then I can find the width by just adding 2 to it. And then of course, just jotting in your entrance and exit. That was like constant, it never changed. So our third question, Matthew has 170 tiles that he can use for his project. Identify the largest patio design that he can make. Show or explain your reasoning. Okay, so I'm definitely not going to have enough room to do that right here. So let me go to a new screen. Okay, drop this. All right. Did that work? There we go. Activity 1.3. Awesome. Like that's looking pretty good. This is what we're on, right? Activity 1.3 with Maureen and Matthew. Hey, so we've got 170 tiles. What's going to be the largest design that will use up all those tiles? So there's a lot of different ways we can do this one as well. I think I might just kind of go like this. We have to find this, to find the maximum number of tiles, those tiles that we were using. Kind of showed you this over there on the screen. We're finding this, we're finding the area of the rectangle. We did the length times width of just the rectangle, and then we added to that the entrance and patio. That's kind of the process I was using with that last table I made with question number 1, the entrance and the exit. We've got the area of the rectangle plus the entrance and exit. So the area of the rectangle, of course, we were finding that by doing length times width. We did length times width. And then the entrance and exit, that never changed. We don't need any variables at all. We always just added 2. So we got length and width plus 2. Okay? Now, in our first design, you guys recall, right, how many tiles we had? First design, the length's 1, the width's 3, we had 2, we got 5 tiles. So I'm going to rewrite this just a little bit to make it easier to simplify for us later on. So instead of using length and width, I'm going to use just D for design number. Is that related directly to the length? So hey, I'm just going to rewrite this. I'm going to say the length's the same thing as the design number. I'm just going to replace L with D for design, okay? And then what do I need to multiply it by? So it gets a little bit complicated maybe. So the width was always 2 more than the design. So I'm actually going to write this like this. I've got my design number, and I'm going to add 2. That's the same thing as the width. The width was always 2 more than the length. The length is the same thing as the design number. This is just going to make building equations easier. So it's kind of an intro of what we're going to be getting into later on in the course. So then add 2. I need to simplify this a little bit. So d times d, that's going to be d squared. D times 2. You guys recall our add distribution. D times 2 would be 2d. And then nothing to simplify there. I'm still just adding 2. Okay, so this should make finding more complex designs a lot easier. You can just plug in the design number. So if I plugged in 1 for d, 1 squared plus 2 times 1, right? I'm plugging in this value for d, and you'll see I'm going to get the same result. 1 squared is 1, 2 times 1 is 2, I add 2, I simplify this, 1 plus 2 is 5. All right, so you could do that for any design number now. You can go to design number 2, plug in 2 for everything. We already did this, I think. 2 squared is 4, plus 2 times 2, which is 4 again. So we really got 4 plus 2, which is 10. Okay. Again, we're kind of just exploring patterns right now. Don't get discouraged whatsoever. You might even find some patterns that are easier for you. Like design number 3, we calculated it earlier, had 17 tiles, right? And so we're coming up with what's the maximum design that uses fewer than 170 tiles. That was the question for number 3. What's his design? What's the maximum design? Because he only has 170 tiles. So check this out, right? We've got, this is going up by 5. This is going up by 7. So if you had to guess, how much is this one going to go up by? It went up by 5, went up by 7. So this one might just go up by 9. And you do 17 plus 9, and you can get 26 that way. So if you'd rather do that and get to the 170 tiles, it's fine for now. I'll teach you some more strategies in actually developing these expressions right here. That'll come just later in the week, possibly at the beginning of next week. Okay? So anyhow, you keep this going. Eventually, you're going to exceed 170 tiles, and then that would give you the answer to that question. Just for fun, you can test this out on your own and plug in maybe 12 for the design and see what that does for you, how many tiles that would be. Try to plug it in yourself and work through it. Practicing using equations, using expressions anyways, is not a bad thing. The more practice, the better you get. Here, let me get rid of this stuff, and I'll plug in 12. So our equation was d squared plus 2d plus 2. So if I plugged in 12, I got 12 squared plus 2 times 12 plus 2. So 12 squared is 144 plus, so 2 times 12 is 24 plus 2. Okay, 144 and 24, that makes 168. 168 plus 2 is 170, so that's it. That would have been like your solution to this problem. How you get there is not a big deal at this point. Just recognizing that there are patterns. You can find patterns a lot of different ways. Like we related length to width, we related design to number of tiles, we related design to length. There's a lot going on here. Even knowing what things are constant, like this right here, the plus 2, knowing that that never changed. That's another pattern. It never changed. We need to know that. And the sooner that you're able to kind of pick these things out, the much better off you're going to be in Algebra 2. So that's going to conclude it for today. Remember, you do have that discussion question to answer. I think it was question 3 from page M1-10, probably. So So answer the discussion question. You've got some patterns to recognize all by yourselves on your assignment, and that's going to do it for today. So hey, thanks for watching, and I'll see you guys soon. Bye-bye.